Do you see a recording button? Yes, it's being recorded, I think. Okay. So, hello, good afternoon, good day to you. Today I'm going to talk about programming in Python for computer-aided design. I've made a repository. The repository will be soon online and shared publicly. In the meantime, I will talk about a little bit about how to share code and work collaboratively through GitHub and VS Code, and I will dedicate the rest of today to working on a Python script or a couple of Python scripts following a couple of presentations. Sorry, this is a national emergency alert from the Netherlands. What is it about? Nothing, they're just testing the system. Okay. Okay, so this is the GitHub repository that I've just made. And I think, yes, I've pushed 2 presentations to it. So let me see. Shall I add you, Elnas, to the repository?
Yes, please.
Okay, let me see. Where do I go? Settings, collaborators. People. And what was your ID?
Elnaz with E capital.
Oh, yeah, you have put it in chat.
Yes, yes.
That's it. Okay. Good. So you must have received an invitation by now.
Yes.
Okay, if you go to this repository, then you can see you can get these 2 presentations for now. And I would like to suggest that you also write whatever you want to take notes from in a markdown document here. I can start the markdown document, or maybe it's better if I do it from within VS Code. How about that, right? So let me clone this repository also on VS Code and show you how you can clone it here as well. So basically the way I cloned it here, this application is GitHub Desktop. I cloned it here by, where is it? Where's the button? There's a button called, oh yeah, clone repository. Yeah. So if you open this application on your computer, this is the desktop, GitHub Desktop. And if you press the file clone repository button, and then before that, prior to that, you can click on this button here, and then click either on this button to copy the code, or just double click here and copy the code here, the URL, basically. Then you can come back here.
Sorry, could you please explain a little bit? Yes.
There's a button here on the repository in GitHub.
Yes.
So this is the address of the repository for people who will see this in future.
The starting page. Let's get started. Shall I push the clone repository from the internet? Yes.
Here, you mean, in GitHub Desktop?
Yes.
Yes, clone repository.
Uh-huh.
And then URL.
And then URL,
And then the URL that you have copied from here, this one, comes here. And then you say clone. Okay.
I can't find the link.
Okay, so once
Where
again,
is the link that I should copy?
this button, this code button, if you press it, then you see.
I do not have that button. When
you don't have that?
No, my maybe my GitHub desktop is. Could it be different? No.
Might be. I'm not so sure. Can you share your screen for a second?
Yes. Let me.
Are you sharing? Oh yeah. Okay. So you must first accept the invitation that I sent you. It probably goes to the email address that you used when you were registering for this account because you haven't yet opened the
Yes.
repository.
I'm in the repository. You've activated the file finder.
No, I think you are on your first page of GitHub. You're not yet in that repository. If you go to your repositories
Let
under
me
your name, on the top right, says your profile. Oh, I lost your shared page.
I wanted to show you the file finder where I
Oh, yes. Oh, yes. Okay. And can you press on the name of the repository? Can you press the name of the repository? Yes.
PyCat.
Yes.
And then
Okay.
code.
Now code. Yes.
Code,
Yes. That's the
copy,
one. Copy
yes, and then paste it in the
and go to GitHub Desktop.
yes. It's cloning.
Okay. I don't see your GitHub Desktop now, but maybe you can stop sharing and I will share again my screen. Okay. So
Okay.
then you must see it here. You must see something happening here. And depending on where you have chosen to clone this, I would recommend, if you haven't yet chosen a location, I would recommend your documents folder, basically a folder that is not synced with um, any online cloud service or whatever. I would suggest such a location for your GitHub folder. So usually my documents is a good location on a Windows machine. So if you choose
Mm-hmm.
My Documents and make a folder in your My Documents folder, call it GitHub, and choose
Mm-hmm.
that folder as a location for the repository, then you can go to your, uh, basically to this folder, as you can see here. In My Documents, I have a folder called GitHub, and in that GitHub folder, I have all these repositories. Okay, these are the ones that I've cloned on my machine. And now, because I've cloned it, basically I've gotten a copy of that repository here on my system. So this has a
Okay.
couple of advantages. Here I can start adding files and folders, and then they appear here, and then I can push them to the repository. And if I pull something from the repository, they will appear here as well. And everything about the history of these files, etc., is just it will be stored on these Git files inside this repository. And that's the whole purpose of Git, because it tracks different versions of files. Okay.
Okay.
But basically from within the same folder, I will start adding files and editing files and everything from within VS Code. Okay.
Okay.
So where are we now? So basically this is how I added these two presentation files. Let me see if I have something else to add just for the sake of this example. Okay, I was in this folder. Let me see if there's an interesting yeah, okay, let me add this conda cheat sheet. Also, it's available online as well, but just for a Python cheat sheet and a conda cheat sheet. Okay, let me copy these two and go back to where I was, presentations. Okay, let me make a new folder, call it cheat sheets. Cheat sheets. Nice. Okay, so I guess now you see them here, you see? They just appeared here. That means that something in the repository has changed from as compared to the online version, and now we can write a small message here added to sheets and commit it. Commit means it's ready to be pushed or pushed basically. And when we say push, it pushes these new files onto the online repository.
Mm-hmm.
Okay.
Yes.
And yes, it's done. So now if you go to your online repository and refresh your page, then you will see that the cheat sheets appear there. And if you go to your GitHub desktop, basically now you need to pull. Well, first you can press this button and say fetch, and then it will probably show you things that need to be pulled, and then you can pull them.
Fetch.
Yes.
Pull
In the
origin.
meantime, okay, on cheat sheet. Okay. Okay.
And then in the GitHub desktop, I should go to Open in Visual Studio or show in Explorer. Explorer.
Uh,
Because when I
okay.
show,
Both could
oh,
work.
okay.
Yes. Yes.
You
Yes.
made a separate folder for the cheat sheets. I can
Yes.
see them.
Yes.
Yes.
Yes. Okay. Great. Let me just add something in Markdown. This format that I'm writing in for the README file is it's a very nice format called .md or Markdown. It's a
Mm-hmm.
way of writing documents for the web. It's actually the coolest way that you can write documents nowadays. I use it for all kinds of purposes, even writing um, PDF files and everything basically. Uh, it has a very simple cheat sheet that tells you how you can make bold text, italic text. This is a way of typesetting, so to speak.
Yes.
Typesetting is basically what you do with something like Microsoft Word, but
Yes.
this is the cool version of something like Microsoft Word for typesetting on the web. You can make tables, you can make URLs, you can insert images, you can do lots of things, and basically this is a 5 minutes tutorial or cheat sheet for Markdown and that I will add here.
It's very similar
Um,
to HTML and CSS.
yes, but those are markup languages. This is called Markdown.
Yeah.
So I don't know exactly where this terminology comes from, but anything that has ML at the end is HTML is hypertext markup language, and MD stands for Markdown. Let us
Mhm.
write our notes in Markdown. And for adding a URL, I basically do this. And when I say commit changes here, basically this is how it's rendered with a link. So you already see one example as to how you can edit a Markdown file. So anything that starts with a hash and space and something will be a title. Anything that is put between square brackets and followed by parentheses will become a link. That's it.
Okay.
Simple.
Mm-hmm.
Okay, so it's good for tracking changes in these files. You might wonder why I bother with writing things in Markdown, because Markdown files are basically human readable. As you can see, they're very easy to read. This is the base file, and they are easily rendered on the web. So you get the best of both worlds. You get a document that is easy to track by means of Git version control, and at the same time you get a document that is easy to write and is nicely rendered, basically. or nicely typeset. And Git basically is a software application that tracks files, mostly text-based files, and tracks changes along each line of the text file in your system. So it's great for tracking programming files and any text-based file, but it's not so good in tracking binary files such as PDF files or basically any sort of proprietary file that is owned by a company that you don't know how to read its file because it's written in ASCII or binary or whatever. It's not human readable. But so it's great for keeping track of files that are code, basically. So I can add a file that is Python code or whatever. And let me just add a Python file because I want to also add, so I call it test.py. And from now on, this is going to be a Python file, import numpy as np. And okay, so as you can see, this is now rendered as a Python file because it knows most programming languages. And it can typeset them nicely as code. Okay. And right now, because I'm directly writing on the so-called remote or the online version of the repository, basically everything is up to date. And now from the desktop or from VS Code, we need to pull everything, as you can see, because now there's a new file, which is now pulled onto my system. So from now on, I will continue in VS Code. Visual Studio Code is the so-called IDE or integrated development environment that we'll be using throughout this course. As you can see, I use it for almost everything, including writing papers, etc. But that's not what we are here today for. Let me see. New window. And okay. And I open it as a folder because I've already cloned it, you see. Where is it? Open folder. File open folder, yes. Folder PyCat. Okay, I do already have the folder, so I open the folder directly. And yes, I trust the authors. I am the author and I trust myself. Let me see. Okay. Okay, so as you can see, everything that I had put online is already here because the folder has been synced using the GitHub desktop application. But I could have done the same thing from here. So you might need to do certain things before you are able to use your VS Code together with GitHub. So please go ahead and check your VS Code and see if you can open this folder. And if you basically see this uh, this icon here with your GitHub account. If not, let's get you started with this. Most probably for the first time, you need to add certain things. You need to do certain things to connect your GitHub account to your VS Code.
I have the folders, but yes, I have the folder.
You have the folder. Okay, that's a good start. Then open the folder.
Download Git. No. Yes.
Wait.
Yes.
Can I ask you to share your screen? Then I can help you directly.
Yes.
Yeah. Okay.
Uh,
You're not sharing it.
I know because okay. Okay. So, can you see it?
Yes. Okay, great. Can you click on the button with a profile picture at the bottom left?
Setting?
No. At the bottom left of your window. Yeah,
Uh,
there's an icon with a profile picture on it.
yes.
Avatar. Yes, account.
Okay.
Okay. Let's see. It will take me some time to figure this out. Okay. You might need to install a couple of extensions first. Let me see what kind of extensions I do have here.
Then I should
Git,
go to extension.
search for GitHub. Yeah, go to the extensions tab and search
Mhm.
for Git. Wait. You probably need to install the Git software application itself. So first go online and search for Git for Windows.
Git for Windows.
Can you share your other
Yes.
screen as well?
Yes,
Because
yes.
I only see your...
Can I share other screens?
Yeah, when you're
Yeah,
sharing,
more
maybe you
screens?
can choose share your window. Share the
Oh,
entire
okay.
screen so I can see your, if you don't mind.
No, it's okay. Um, share. I should stop sharing and then reshare again.
Yes, that's okay.
And I think yes. Okay. Entire screen. Can you see it?
Yes.
This is Git for Windows.
Yes, exactly.
On, and
Yes.
then download.
Okay, so in the meantime, I'm looking at the extensions that I have, which are about GitHub, and I'll give you a couple of names to install. Okay, great. So let's go ahead and install GitHub pull requests. That's the first one. I think it was already the third one showing up. GitHub pull, yeah, the third one. Pull requests, yes,
Okay.
that's the first one now.
Yes.
There's a bit of a delay. Yes, that's the one. So install this one first. And what else?
Git. Oh, no, it's not downloaded yet. Okay. And then, are there any other extensions?
Okay, yes.
Shouldn't pull,
There are a
correct?
couple of more extensions about GitHub. One is called Git Lens.
Git lens.
One S. One S and nothing afterward. And it's one word, yes, Git Lens.
No
Did you find
extension.
it?
Lens. Oh, yes. I found
Yes,
it. Yes. And then, what
yes.
else?
And the other one is called Git Graph.
Git lens, it's being installed.
And while we are here, let's also install some other important stuff like Python
I have Python on my.
on your VS Code. You have it? Okay. And do you have Pylance as well?
No. I don't have Python on my VS Code.
Okay, so let's install Python and Pylance as well.
Should I just click on next for Git Windows?
Yeah.
Yes.
Yeah.
Okay. And then you said Git graph.
Mm-hmm.
This Git graph. Oh,
Yes, that's
yes.
the one.
And then Python or
Let me see if there's anything else about Git. Not about
Python extension or
yes,
Python?
Python, the biggest one. So the most number of people. Just Python. It's called Python. Yes.
Okay.
Okay, and then if this is installed, then there's another one called Pylance.
Pylance.
Lance. No, CE.
Pylance.
Yes. Yes. Okay. And let's also install Jupyter or Jupyter. Let me see. Launch git bash. Okay. No, it's Jupyter, so like Python. Your dictation is correct, but not for Jupyter. I call it Jupyter. Most people call it Jupyter because it's actually the wrong Jupyter with a reference to Python.
And is
Yes,
there a H
that's
after
the
T?
one. Yeah. No, that's the one. Jupyter. Yes, the first one. 66 million. Is that
64 million.
64 million? Yes, that's the one.
Okay.
And while you're at it,
Was installed. I don't know how, but it was installed.
maybe it comes together with the Python.
Yes.
Okay. Would you like to have also a couple of things for Markdown?
Yes, please.
Okay, so let's install Markdown PDF. This is a cool extension that allows you to directly create PDF files from Markdown. Yes, that's the one. And there's another cool one that renders the Markdown files nicely. It's called Markdown Lint. Lint, Lint.
This one.
And there's one more thing that I'm very curious about that I haven't yet checked it out myself. It's called Markdown Presentations for VS Code or MARP for VS Code. If you're curious about Markdown, then you can check this out. It's a very cool application, as far as I understand, that allows you to write very simple Markdown files and get exquisite quality presentations out and convert them to PowerPoint or other formats for slides for presentations. It's called MARP.
MARP.
MARP. Yes, Markdown Presentation or MARP.
Uh-huh.
Yes, that's the one. Anyhow, so
Okay.
this is something for cool kids, and I'm sure you want to be or you are a cool kid already if you're following this tutorial. Okay, for now I think we are set. Let's go back to VS Code, to your VS Code page.
Okay.
Okay, so can you click on that button again, the button with an avatar or profile picture? Yeah.
Yes.
Okay, you don't see it yet. Okay, try this. Press Ctrl Shift P in VS Code.
Yes.
Okay, and type reload window. Yes.
And then again check.
Mm-hmm.
What am I supposed to see?
Turn. Okay. Now I know what to do. Turn. Click click it again. Click it again.
Uh-huh.
And say turn on remote tunnel access. Uh-huh.
Enable.
In view. Yes. Okay, sign in. Yes, exactly. Click on that. Sign in with GitHub. Yes, exactly. Exactly. Authorize VS Code. Yes. Yes. Allow an extension to open this URL. Yes, open. Okay, something is working. What does it
Copy
say?
browser link.
Copy
You
version.
can now access
Okay,
the session. Where? Okay.
And then go click on
Choose
that
session or
button again.
uh-huh.
Okay,
GitHub.
perfect.
Manage trusted extensions.
Yeah, I think you are in. You are in now. Okay, so go to the Files tab on the top left.
Yes.
The icon, actually, the Files icon
Uh-huh.
below it. Yeah. Yes. Yeah, the one below. On the menu bar on the left. Yeah, the top icon on the menu bar. Yes.
This one,
Yes,
Explorer.
Explorer. Yeah.
Uh-huh.
Okay,
Uh-huh.
so
I can step you
that.
back there.
Yes, okay. Let me do something on the remote repository. I will add another file. I will add a Jupyter notebook file. In the same way that I made that file, I just make test.ipy notebook, import numpy as np. Okay. And okay, so go to your VS Code again.
Yes.
And press Ctrl Shift P.
And then type what?
Type pool. Git pool. Yes.
Okay.
Okay. Okay, it's working apparently. Okay. Sign in. Wait. Sign in with your browser. Yes. No, the one. Yes, that's one. Okay, approve it. You need to approve it again. Yes, that's That's the other. No, it's the other.
I have an email, I think. Yes.
Oh yeah, that's just a warning apparently.
Okay. I have a
Yes,
notification
perfect.
here, but
It worked because now you have the
okay.
test IPyNB, which is interactive Python notebook or Jupyter notebook. So you have the newest file
Yes.
that I've just committed here. So basically you are in. Welcome to
Oh,
GitHub.
thank you. Thank you.
Okay. Okay, so let me see. I need to do the same on my front, pull it. Okay, let me show you another cool window here in VS Code. Click on the Git icon in the menu bar. Yes, that you just passed through. Right below the magnifier. Yes, that's the one.
This source control.
Yes.
Okay.
Basically, source control is Git. So if you press the commit button,
Yes.
yes, okay. Now you see basically all the buttons that you need to push every now and then. You can pull it up a bit. Yes, exactly. So there's one that looks like a recycling icon. I think that's the one that is called fetch. If you hover on it for a second. Yes, fetch.
Yes.
That one checks the status of the repository on the remote or the online repository. And
And
there's
refresh.
another one next to it, which also looks like a recycling icon. That one is called
Refresh.
refresh, probably. Yes. Either of the two should be pressed first or, I don't know, second. And then you get a
The news.
notification whether there's something to pull. And then something shows up at the bottom of your window. Let me create one new file and then you will see.
Okay.
I will create a markdown file on my system. Let me see. Workshop notes or just notes and then notes w0 dot nd. Okay, notes from workshop number 0. Okay, and save and commit and then workshop notes and push. I should have shown these, but anyway, it doesn't matter. Okay. Okay. Now I hope you can pull it. You can press those two buttons and see if there's something appearing over there. Yes, you see it shows you changes to pull from origin on GitHub. Okay. And then if you go down, down, right at the bottom of your window, you see another recycling item button, another button that looks like a recycling icon. Yes.
On the bottom. Oh,
Yeah,
yes.
you can push this and this will pull and push. If you have something new to push, it will do this. Or you can always also press Ctrl Shift P and it will, and then you can type the command git pull and it will do exactly the same thing. Okay. Okay, now you're all set and let's create also and push a file from your system so that you have seen most of the relevant stuff from Git here. And
Okay.
okay, go to your Files tab. Sorry, the Explorer tab. No, the
Yeah.
iconic. Yes. Okay.
Yes.
And for instance, press the notes. Yes, that one. And go to the first one. Yes. And just go to the next line. Oh, first I have made a small mistake. So there should be a space between the hash and the what comes after it. So put a space between hash and notes. Okay.
Okay.
Then go to the next line
Okay.
and type something like today we first learned how to work with GitHub.
How to get out?
How to work with GitHub, something like in VS Code, something like that. Okay, so now you have a new thing to commit and push to the file, and just press Ctrl S to save it. Suppose this is a new piece of code or something that you've added.
And where it was saved?
Uh, it is saved directly on the file. Okay, now you want to commit it. So press Ctrl
Okay.
Shift P.
Then I type
And then
commit.
commit, git commit, yes.
Yes. Yes. Would you like to stage all your changes to commit them directly? Yes.
Yes. Okay, I should help you get rid of this thing, but okay, for now, type a message here. Say, for instance, added a line to the workshop notes number 0. This is a message that you write for yourself in future to come back to this commit and remember what you did here.
Okay.
So write in the past tense, write added a couple
Yes.
of added a line to the workshop notes number 0, something. Yes, exactly. And I think you can press the check mark on the top right and close it. But this is a bit annoying, so I will help you get rid of it.
In future.
Yes.
And then commit again.
Yes.
Okay.
No, it's already committed. It's already
Oh,
committed, so
okay.
there's no change to commit. Now you can Control Shift P and then push Control Shift P and git push this time.
Okay.
Push. Okay, great. Okay, now I will pull and I will pull here again. To be on the same page. Okay. Okay, good. So now I do have the same file as you have. Okay, where were we? Now I want
And
to
any
go.
change that I make to the file and then save it, it will refresh for yours. Okay? Yes?
Sorry, what?
If I make any change to this note and then
Then
save
you can
it,
save it and commit it again and then push it.
I should comment it again and push, and
Yes, yes.
then you can see.
Always in this order, but it's a good idea. It's a good habit to first always pull to make to make sure that you're on the first page on the same page as your collaborators,
Uh-huh.
because otherwise you may get into conflicts, because basically it is keeping track of all the changes on the text files that you're sharing with your collaborators. And your collaborators can sometimes be just yourself in future, right? But
Yes.
it's a good idea even if you're working alone to work in Git, because you can at least track your changes. But of course, if you work with other people, it's even more important to use Git for tracking changes. Okay, now let me switch to another topic. Uh, shall I show you first how to get rid of that little thing? It's basically okay. Basically, I can show you how to get rid of it interactively. The most important skill of a programmer nowadays is searching in Google for problems and finding a solution.
Yes.
So let's search on Google on Stack Overflow.
Stack
Type
Overflow.
type this. So basically, with Google search, the most important skill that you need to have is how to formulate your question, and secondly, how to write your question. So let's say we
Yes.
know how to more or less how to formulate this question, and the important thing is to write the context first. So instead of writing how do I do this in VS Code, we write
Mhm.
VS Code, how do we do this? Yes,
Yes.
VS Code, how to get rid of the commit message, something like that. Exactly, in Git, whatever. Yes,
With
commit
this
panel
cape.
VS Code, and let's go to the first answer on Stack Overflow because this is where I usually search for answers, and I would highly recommend that you also open an account here.
Super user.
Probably, yes, that's also from Stack Exchange. Yes. Yeah, so let's open both of them.
Stack
Yeah,
Overflow
the
and
first one
super
and the
user.
second one, yes. I think the answer
Okay.
is on the second one, but the super user is also from the same platform. So why do I say this? Because I think in the past people had to learn long books for learning programming. Nowadays, you follow a short tutorial, and most of your job as a programmer is about searching Google for answers. So, and
Yes.
it is a social phenomenon. So you need to have accounts on these forums, and you need to know the rules of asking questions, and you need to know some basic tricks on how to as to how you can or you should formulate your questions. And some of these fora are very strict in terms of how they accept questions. Okay, so it's a very good idea to familiarize yourself with these kind of fora. Okay, go up a little bit and accept the cookies. Yes. Okay. So with the escape key, where is it? How do you close the comment? Blah blah blah. I would go to the first answer that has the highest votes. Let's go down. How do you close the comment button? Go down.
Highest votes. This is the number of votes.
The
So this one has more votes.
5. Escape
Yes.
by clicking second part of the. No, this
Header.
is. Ah, yeah. Let me see. No. Go to the other one from VS Code. I think this one doesn't do the job. Accept
Hide the comment and
cookies.
push button.
Go down.
This one wants to hide the comment and push button. Should I click on this?
There is a setting in VS Code to hide this button. You may read the release notes. No. If you go up, basically this forum is very strict for not repeating questions. So somebody has commented that this question has already been answered. If you go up, yes, click on, no, wait. This question has already been answered here. So press here. Exactly. Go down. Okay, that's the one. That's the one. Okay, so we have to open your VS Code settings for Git. Go down. Maybe there's another answer. Is there a better answer with more votes?
No.
No?
This
Okay.
one, 7 no. This one with 13 no votes is the
Okay.
best.
13 votes. Okay, so let's go to what they're mentioning over there. So this is a new setting, enable, disable, git commit, push sync buttons. Okay, wait, show action button. Okay, so we want to basically open the settings.json file. This is a JavaScript object notation or JSON file that includes all the settings of your VS Code application. So let me tell you how to find it in VS Code. Let's go to your VS Code.
Okay. Excuse me. I didn't understand what is the problem at first. What is the problem?
It shouldn't ask you for opening this annoying commit message thing. It should just give you a single line to write your commit message, and that should be it. But when you are new to VS Code, it always assumes that by default you want to open the message file and you want to write a fancy file. We are trying to get rid of that annoying step to make it quicker to commit.
First line, notes from workshop number 0.
No, not here, not here. You remember you opened a file was opened automatically after you said commit. That
Yes.
whole big file was to take note of what your commit message was. And that's a little bit too much, and it's annoying when you are working hard in VS Code.
Uh-huh.
So we want to get rid of it.
Okay.
So if you press the settings button
Yes.
and settings, exactly. Okay, now use Control F
Control F.
on this page
Yes.
and search.
Commit.
No. Yeah, maybe commit.
Uncommitted change format. Commit level description tooltip.
We have to go back to that file, to that answer, basically. What were they saying? No, the one with highest number of votes. I mean, I could look it up and tell you, but this is part of the experience, so that's why I'm bothering you with
Yes.
this.
No, it's okay. Where are the votes here? Yes. Here there is new setting to enable the show action.
Okay, so search
Action button.
this phrase, show action button, yeah.
Okay.
Controls whether an action button can be shown in a source. No. What do they say? That we should uncheck it or what?
No. This one, all of them should be checked. So
Checked.
enable,
Okay.
disable this git commit publish. Enable, disable, or this is in your setting.
They should all be false.
Unchecked, yes.
Unchecked. Okay. Okay. Then let's see if it worked. Press Ctrl S before closing. Oh, you have to open it again.
Yes.
The settings file.
The settings. Oh.
Search for action button.
Oh,
Yes. Okay.
here.
And
Okay.
go to the notes, write another sentence, and try to commit again. Right, we just checked how we can change the settings of VS Code. Okay. Okay. Great. And Control S and then Control Shift P, git commit.
Yes.
Yes.
And then push.
Oh,
no.
no. Basically, it didn't do the job. Let me see. So we didn't ask the question properly, apparently. VS Code git how to get rid of the commit message. Okay, found it. Did I find it? No. Good idea to read those.
Settings.json. Where is settings.json?
Ah, yeah, found it. Okay, so I will send you this in the chat. Open this page. And did you open it?
I just have that open when I try to commit
Go
it. Yes.
down, go down. It's a bit of a delay, I think. Can you still hear me? Yes. Okay. Search this one in your settings, and that should do the job. In yeah,
Search
open
what?
the settings file.
Okay, and search what?
Search that phrase, whatever it was. Use editor as commit.
Yes, and then uncheck it.
Yes.
Control S, and then
Close it. Okay.
yes.
Write another line.
We just found another.
And please paste the link for this solution here. Or basically write the answer already.
Okay. Commit, underline,
Message.
edit, message. It was in
Okay, so let's use a little bit of Markdown magic. After this link, put this link in square brackets.
Put this link in square brackets.
Yeah. And then add parentheses afterwards. And in between parentheses, put the link. Exactly. And now if you want to see how it renders, there's a little button on the top right that has a magnifier on top of it. No, two to the left.
This one?
No, two to the left of it.
Yes.
Yes. Press this. It shows you how your Markdown
Will be rendered.
would not register service. What is it? Error. Save it. This is a bit funny.
Did I do
Shouldn't
anything
happen.
wrong?
Anyway, it should work out. Reload your window for one more time. Control-Shift-P reload window. And then Control-Shift-P commit.
I have an error here. Download failed. Server return code. It seems that some of the extensions are not working properly. Yeah? Markdown PDF. We don't need it yet.
No. Doesn't matter.
What should it?
Doesn't matter. So let's try to push these new changes and see if we manage to do one thing.
Yes. We first commit. Yes.
Okay. Okay, now you can type your message already in that line. Just type a short message over there. Yes, exactly. We basically never write very long commit messages. Added a line for a solution to the Git message. Something like that.
Okay.
Yes. Okay, and then Control-Shift-P.
Push.
Push. Perfect.
It's working. Yes. Would you like to periodically run git fetch?
Yes. Yes.
Yes.
By the way, if you want to have a line of space between the lines, then you should really give. If you want things to go to the next line, then you should put a line of space between them in your Markdown file, because right now they're all after each other.
Yes, like this. Yes.
Exactly.
Okay.
You can commit this and push it again. And this helps to make it a mechanical habit. Commit.
Would you like to
Save
say
all.
what I saved?
Okay. Yes.
Fail to save the content of the
Added space between the lines. Okay.
It's been here. Failed to save commit edit message. The content of the file is near. Please compare your version with the file contents or overwrite. Yes, overwrite.
Override.
Yes. Okay.
And then push. Perfect.
Where can I see these comments that I wrote?
The messages.
Yes.
If you push the button for source control, basically the Git button, the Git icon. Yes.
This one.
Yes.
Source control. Yes.
You see, your commits are actually identified with their messages. And suppose something goes wrong, let's say in 2 hours after working for 2 hours, and you want to go back to basically where you were 2 hours ago, right?
Yes. Yes.
Then you can right click on one of these commits and read the message. And remember that this was the last time when everything was still okay,
Yes.
right? And right click, hover on one of them and right click. And basically you can revert or rebase or reset to that commit. So they have slight differences, and honestly I have to look up the differences when something goes terribly wrong. I have to look up the differences and I will check them when I need to. But
Yes.
one of these four options do the job. One of them does the job. Yeah.
Okay.
You either revert to that commit, or you reset to that commit, or you rebase to that commit. So it brings you back basically to that commit, to the state
Yes.
of your code at that point in time. And that's the whole point of source control. And I think this is a good moment to wrap this up for now
Yes.
and get to a little bit of an overview about coding inside Rhino and Grasshopper. Okay, if you stop sharing. Okay. Okay. So this is one of the two tutorials that I've put over there in the repository. I will change them a little bit afterwards. But basically,
Yes.
what I wanted to tell you today is what is the big picture of coding in Rhino and Grasshopper. Later, I will extend it to outside Rhino and Grasshopper, but because Rhino and Grasshopper are the most used platforms for coding in the computer-aided design or in the architecture, engineering, and construction industry, um, we will use them as the base for coding, but we will also try to use something else, which is called Compass framework for coding computer-aided design applications outside of Rhino and Grasshopper. And hopefully we will also get to use something called Speckle for connecting to the outside world, of the world outside of Grasshopper and Rhino. But basically, what I want to tell you is, which uh, is followed by a couple of small assignments, is basics of scripting in Rhino and Grasshopper. First and foremost, what needs to be said about Rhino and Grasshopper is that all the tools that operate on the geometry actually come from a library called Rhino Common. They basically come from the kernel of Rhino, which is a library called Rhino Common. And this is what most people don't know. So anything that you need to work on with meshes, with surfaces, curves, points, etc., etc., all the geometric data, data types, they all come from this library called Rhino Common. And if I can offer you and everybody listening to this afterwards a piece of advice, please stay away from RhinoScript. I don't recommend that you use this. And of course, RhinoScript syntax in Python. It's better to use directly the Rhino common, which is rhino.geometry namespace inside Python. And why would you need Grasshopper kernel? Grasshopper kernel is another kernel, is another library that you may need to use in programming inside Grasshopper. And the only good reason I can think of for using Grasshopper kernel is when you need to write a data tree for Grasshopper. You need to work with Grasshopper kernel, for which you need to download a small file called the Grasshopper SDK or Software Development Kit. To get that, type this command in your Rhino command line, Grasshopper get SDK documentation. If you have your Grasshopper open, please type this command and you will get this little file which is called Grasshopper SDK. Do you have your Grasshopper open already? Or Rhino? If
Yes.
not, please open and then type this. It will download a small library of documentation library for the Grasshopper kernel and place it on your desktop or somewhere that you remember.
Okay.
Okay, so, and the important thing about Rhino Common, or the library of geometry operations in Rhino, which is shared in Visual Basic.NET, a language that I would recommend you not to use, or C#, Again, I'm not a big fan anymore. I used to be C# programmer, but I've switched to Python. And Python in Grasshopper, they all use the same geometry operations from the same library. So it's very important to know how to learn how to navigate yourself through this library. Now open it here. So these are the namespaces, the so-called namespaces in the Rhino common library. And the most important one that you need to do most of the stuff with is rhino.geometry. A namespace is a place in a library, is basically a folder in a library where some data models and methods or operations or functions that operate on those data models are defined and placed, right? So most of the stuff that we need to work with are here. So if you ever need to do something with arcs, they're here. If you ever need to do something with Bezier curves, they're here. If you ever need to do something with boxes, they're here, etc. Let's check boxes, for instance. This is how you can construct a box from scratch, from another box, from a bounding box, from a base plane, from another geometry, from a base plane and a bounding box, let's say, or from a base plane. This is the one that I like. Base plane and an enumerable of 0.3D. So even if you're not programming with C#, it's important to know a little bit about this kind of writing, which comes from C#. So it first tells you the name of a so-called method or function. The function is called box. And inside parentheses, you basically see the arguments of the so-called arguments of the function, the input arguments of the function. And the arguments of a function are basically the inputs of the function. Don't ask me why they're called arguments, because they are called arguments from mathematics, perhaps. And or in French, argument. Okay, so these arguments of the function are two in this case. The first argument is of type plane. So the first keyword here is a type keyword, plane. It's a plane, and it's called base plane. So the second argument is called points. And what's the type of it? It has a type and it has a data structure. The type is 0.3D, and the data structure is enumerable. So basically, enumerable is something like a list or an array of points, because there are innumerable objects inside. And the type, the data type, the geometric data type is 0.3D, or point with three doubles. So this is a little bit of the jargon that you need to understand when you're here. When I click on it, it shows me that I can make, well, it brought me basically to the main page with everything. Okay, so this was the one. So a plane to be used as a base plane and a list of 0.3D called points. And okay, let me tell you something very clearly. This documentation is not very nicely structured, and sometimes you face big issues with searching stuff in here. Don't get disappointed too quickly if you cannot find something, or if it doesn't seem intuitive to you. Most of the stuff are here. You just have to be patient and a little bit resilient to find them here. Okay. This is not the best documentation that I've seen, let me put it this way, but most of the stuff are here. So you need to be a little bit stubborn with this documentation. Let me get back to the file before I lose the train of thoughts. Okay. And there's a similar documentation for the so-called Rhino script, which again is something that I recommend you to not use. So basically, whatever you do, code inside Grasshopper, you code inside one of these three components, and there's a new one added to them. The C# component we won't work with here in this course. The Visual Basic one we won't work with, but basically they all have the same structure. Inside them, you can write a function, and inside the function, you can write code. And inside this code, you can use the libraries that you have imported to your component. Okay.
Mhm.
And in addition to this one, which is called GH you have a new component called CPython for Grasshopper. And I recommend you to install it for your Grasshopper. And you might wonder, what's the point, So we have Python. Well, it sounds like you have Python, but you actually don't have real Python inside Grasshopper. What you have is something that we call Iron Python. It's another library of code for working with .NET code, which is C# and Visual Basic, uh, which are the languages with which Grasshopper itself is written, to work with Python. So long story short, trust me, you don't have access through Iron Python to the good libraries of Python. That's why you need the other one as well. The other one is called CPython, which is the standard Python as you know it outside of Grasshopper. So long story short, you need this plugin called CPython for Grasshopper. This is the library, CPython. Where do I find it? Food for Rhino. CPython. This is the library that I'm talking about. Okay. Probably as we speak, there's a better solution already out there, but I haven't yet tested those solutions. So this is still the one that I recommend you using. I recommend you to use. Okay. Shall I put it in the chat? Let me see. Where is it? Where is the chat? Where is the chat? Okay. Okay. The newer solution that is probably out there by now is Rhino code, which allows you to directly use both the Rhino geometry commands and Rhino and other Python libraries inside a Python component. Okay, I already said something about data types, but let me say it more properly. Data types are things like floats or strings in programming languages. So if you want to write a message like hello world, you write it as a string. And a programming language like Python is not very sensitive to data types because it's so-called dynamically typed. It's a so-called dynamically typed language. Um, and some programming languages like C# are very sensitive to types, and they're statically typed. So as soon as you declare something, you tell what it is. In C#, for instance, you say plus as a function has two arguments, A as integer, B as integer, and it returns also an integer. And this is the format that you see, sorry, this was Visual Basic. This is the format that you see on the documentation of Rhino. It shows always the type argument first, integer A, integer B, and the whole function is basically an integer, which is called plus. That means the function so-called, so to say, returns an integer. You might find this keyword return a little bit strange. If you want to think about it figuratively, I would say there is a cursor that blinks in your file, programming file. Return means return to this place and bring me back a number, something like that. This is an old keyword in many programming languages that means returning the result to where the cursor is, basically. Okay, as you can see. So where you call this function's name, then it returns the result of the function over there. And what is a float? What on earth is a float? So this is a very important data type, a float data type, because real numbers do not exist in digital computers. And this might sound like a big disappointment, but this is something that they need to know. So a real number like the square root of 2 does not exist as such, or pi does not exist as such in a programming language for a digital computer, because you cannot have infinite precision points after the decimal point, because you have to cut it off, because you have only a certain number of bits to represent a number or to represent any other thing for that matter. Okay, so you have um, floats or single precision or double precision floating point numbers for representing numbers with a certain number of decimals. In Python, we will use floats. Okay. In some other programming languages like C#, you have double precision and single precision floating point number parameters. So this is a data type. So we are representing a number, we represent it as a float, we represent a string of characters or text as a string. And sometimes in addition to data types, we have data structures like lists or arrays or matrices or things like that. And data types are to help us access the right methods to easily work with them, to process them. So if you don't know something is a number, how can you know that you have a function that is for adding two numbers to each other, right? Or if you don't know that something is a string, how can you know that you can operate on this string and find, for instance, the characters of this string? So these are some of the so-called primitive or basic data types inside Python: integers, floats, booleans for true and false, and strings. And you also have hashables, or the so-called hashables, or enumerables, or um, data structures. The basic data structures that are available are lists, tuples, and dictionaries in Python. So what are lists? Lists are marked with square brackets in Python. So as soon as you put these two strings inside square brackets, you have a list of two strings. The first one is a string of characters that reads as hello. The second one is a string of characters that reads as world. Okay. Basically, at this level, they all seem to be the same kind of thing. At least these two are very similar, the list and the tuple. Why is it called a tuple? It's basically a generalization of the word double. So you have double items, you put them in a tuple like this. You can have triple items, you can have quadruple items, quintuple items, sextuple items, or in general, tuple, multiple items. A tuple of multiple items. Tuples and lists are very similar, with the only difference that tuples are
More than two.
no, both of them can contain more than two items. The They are called immutable objects, which is a fancy word for saying that they cannot change once you declare them. But lists can more easily get updated. Anyhow, um, tuples are like, what is the, yeah, something like a point you represent with a tuple, for instance. Something like a list of points you represented with a list of points, because you may want to add or remove points to that list very often. And what are dictionaries? Dictionaries are useful in certain situations where you want to mark certain things exactly like a real dictionary. You mark a chapter of a dictionary with the letter A or with the letter H. So you put something that is called a key, which should be an immutable object like a tuple or a string or a character, something that be that cannot be confused with another thing, some immutable object or unchangeable object, something that cannot easily be mistaken with something else. use it as a key, and then you store the items in the chapter in that key after this colon, right? So in the chapter hello, it's written world. So they basically serve completely different purposes, but don't worry so much right now. We'll get to them. Basically, the next most important item is what we call flow control mechanisms. If you don't have flow control, basically an algorithm is nothing but a sequence of operations. But most algorithms have a non-trivial sequence of operations. That means they have flow control mechanisms, non-trivial flow control mechanisms. So if you remember from primary school or high school, we were taught a procedure for finding the square root of numbers. That procedure is basically an algorithm, which I don't remember by now, by the way. I will struggle if I were to repeat that procedure on a piece of paper as an algorithm. But you roughly remember what that procedure is, I hope. You were to guess, if you were to guess what would be, for instance, the square root of 14, we would have to find the biggest whole square number that would fit in for the number 14, which would be 9. The square root of which would be 3. And then if we were to guess what would be the square root of 14, we would guess it would be 3 and something, right? And so on and so forth. So these kind of procedures, which are non-trivial in terms of flow control, are written as algorithms with these kind of keywords. If and then something happens, or else, if this is not the case, something else should happen. Else, if this is the case, something else should happen, etc., etc. Or while this condition is true, do this, this, and that, right? Or for some number in some range, perform some operation a certain number of times. These are the so-called flow control mechanisms. And if you know these kind of things, then you know how to program. Basically, this is called the syntax of writing in Python, a flow control mechanism for if this, then that. If x is smaller than 5, then print x is smaller than 5. Else, else otherwise, if x is smaller than 10, which means that now, pay attention to this, x by now is smaller than 10, but also bigger than 5, because if it was smaller than 5, it would have appeared here. And if it's bigger than 10 and is smaller than 15, then it appears here. And if none of the above is most probably bigger than 15, so it appears here, right? So this is a flow control mechanism. While x is larger than 1, print x is larger than 1. Otherwise, and then afterwards, subtract 1 from x. Can you guess what this piece of code does? We start with x equals to 10, or let x be equal to 10. This equality sign is not about checking equality, it's about assigning 10, the number 10 to x.
Yes.
So always read it as let x be equal to 10. Okay?
Assumption. Yes.
Yes. We assume x to be equal to 10.
Yes.
While x is larger than 1, this is a condition or a predicate that can either be true or false. Is this at the moment true or false? This is at the moment true. At the moment, x is larger than 1. Then
Yes.
print this statement, x is bigger than 1. Then let x be x minus 1. This is not an equality test, by the way, right?
Yes.
If we wanted to check equality, then we had to write it here, and we had to write with a double equal sign. That would be for checking equality. But this one basically assigns the amount of x minus 1 to x, which is 9. And then the next time, so I said this is a flow control mechanism, right? So instead of just going to the next line, while we are here, we go into the so-called scope of this code, which is these two lines. We do these two
Yeah.
operations and come back here. The cursor comes back here. So that's why we call it flow control, because it doesn't let the cursor go to the next line. While this condition is true, we always come back here and check the condition. So the next time we come back here, x now is equal to 9. Then we read the condition, is still x larger than 1? Yes. Then we go into the scope, do these two things. Print this statement one more time, and do what? Subtract 1 from x, assign 8 to x, come back here, and so on and so forth. So the last time this happens is when x equals 1, right? So we must have
Yes.
printed this statement 9 times. For the last time, x equal to 1 is not larger than 1, so nothing happens, so we go out of the loop and nothing else happens
Okay.
because there is no other instruction after this loop. Good?
Yes.
Okay, so this is it. So this was flow control. The other important thing is defining objects or defining data types, because what if we want a data type that is not written inside Python itself? Something like a point data type, for instance, right? Python itself doesn't have a data type called point. So if you want such a data type, then we should write it from scratch. Yeah. So this is a list. Let y be equal to 0, 1, 2, 3. This is a list of numbers. For every item in the list, oh, sorry, we are still in flow control. I'm still explaining flow control. This is another type of flow control mechanism. For every item that can be called x in the list y, print x. So it is easy to guess what this piece of code does, right? It prints 0 and then prints 1 and then prints 2 and prints 3, because this is every item in the list. So basically Python is very similar to normal English. For x in y, print x. For every item called x in the list called y, print that item and go to the next item. So while we are at this, we come back here as many times as necessary. This means for each item that is called x in the list that is called y, print x, come back here, print it, print it, print it, until we're done, right?
Yes.
Okay, so this is another one. Maybe this is something for the next session, object-oriented programming. But just because I mentioned it, the two more important subjects about Python. One is how to write functions that do something, and that is with the keyword def for definition, giving a function name and writing a function. So basically with functions and flow control mechanisms, you can write all kinds of algorithms. You can do all kinds of complicated things, and that means you know programming in Python. So you basically know already how to program in Python. You might not believe it, but you already know it, because that's it. Functions and flow control mechanisms and data types. And this is the shortest introduction to Python.
Yes.
And basically the only advanced thing that you need on top of it is how to write objects or how to define data types from scratch. And that's advanced programming. And basically that is done by writing the keyword class. You call it a class. Don't ask me why they call it class, because it's customary to call them classes, but basically these are types. I would have called them types. But basically with a class keyword, you write a data type and you call it a class, and you initialize it, and then you can create objects of that type. For instance, you can create a class called it voxel and create voxels or volumetric pixels and so on. So this is the rest of this, and here we have an assignment for creating voxels inside Grasshopper. I have written the assignment as a pseudocode or something that looks like code, but it's not code. And basically it has flow control mechanisms, like a for loop and if this then that sort of mechanism. I've written it in two styles. One is a so-called mustache bracket or curly brackets or C style, which is similar to Java and JavaScript and C sharp for those who want to write in C sharp. And this is the other style that is more similar to Python. But in Python, you don't have then or next. This is very similar to the style of MATLAB or Visual Basic or Basic. But basically, you get the idea what this is about. We want to create a bounding box out of a BREP object. Then we want to fill in the bounding box with voxels of a certain size. And then we want to measure the distance of every one of those voxels to a certain object. In this case, the object inside the bounding box is a cone. And according to the distance, we want to attribute a color to them. The closer they are, the hotter the color. The farther they are, the bluer or the colder the color from the object, both inside and outside the object. Yeah. And this will be the first assignment that we will do. And that assignment will basically teach us everything that we need to learn about Python inside Grasshopper. I had it open here. Basically, a cone object as a brep, and the whole thing starts as this. So we define it as this is a Python node, GH node for now, and this is a CPython node. After you install it, you will have this one as well, which we can use. And this one is the GH node here. What do we call it? Call it S for solid. Is that good? No, not a good name. Let's call it solid. Okay. And I can give it a type brep, and I can come inside. I suggest that we delete everything and start from importing rhino.geometry as RG. Basically, now we are inside this code component, and I can read solid dot, and I don't want to get its bounding box, but it probably doesn't recognize it yet as such. So let me see. Solid dot. I saved it to let it recognize it. And I am looking for get bounding box method. If you want to know how to work with these methods, then you can go where do you guess? Rhino Common Library online. Basically, it shows you this in this documentation, all kinds of these things that you need to know about the method. Basically, how to use the method. As you can see, when we want to get a bounding box of an object, we have to have a plane along which we want to get the bounding box. So here I just use my memory because I know that the data type is a plane. I say rg.plane dot world xy plane. And I assign this to one of the outputs, A equals this. Let me see, what did we do? Yes, now I managed to get the bounding box of the object out. Okay. Shall we call it a day for now? I will.
Yes, it's more than a day.
Okay, so I will save this file here in the repository PyCAD. Okay, so let me
Yes.
create a new folder here. How do we call it? Code
GH.
and maybe one with GH files. How do we call it?
Bounding box.
Voxel, cone voxels, because this is supposed to grow bigger. Okay. It's not, well, if this is empty, then you will fill it in. Until the next session. And wait, what else did I want to do? Okay, we can also do this. We can also save this file as a Python file. That's a good idea, because we will try to do as much as possible inside 2 or 3 components, one GHPython, one CPython, and one more GHPython. One GHPython for input, one CPython for code, and one GHPython for output, right?
Okay.
So that's going to be our convention. Let me tell you why, and then we are good to go. Okay, so why do we do that? So let's say we will generate something that is a geometric, we will have to read something that is a geometric object from Rhino. Here inside this GHPython code, we have access to Rhino command. That means we can process geometry. Then we can process some data types that are probably not geometric. And if we want to do something advanced, we have to do it inside the real Python, which is only accessible inside this one. We do it here. And if you want to visualize them again, here we don't have access to geometric stuff. So we push them out of here and we use another GHPython code component to visualize stuff. So input, output, code, right? So how do we call it? Then we call it export as code. Py, no, Py is not necessary. Cone voxels input save. Okay. Okay, I'm not sure we will use this one for now, so I close it for now. Okay. And I save this file again. Okay, now guess what? These files are now synced here.
Yes.
So I have to commit them.
And then push. No, pull.
Okay, so as you can see, I'm 2 commits behind the remote. So I have to first pull and then push. This is per se not dangerous because they're not on the same files. Otherwise, it would be a little bit tricky. I would probably get into conflicts. But right now, if I just press this button, everything works fine, I hope. Because I will download the 2 that I'm missing and I will upload the one that I've made. Okay?
Yeah.
Okay. So shall we stop now? Or maybe I can show you something else. So this was one file. This is another file in which I can show you the idea that I was talking about. This is another file, an advanced file for uh, voxelization and creation of these blocks, like Lego blocks that have overlaps with each other, or making some object like this with Lego. Yeah. So the
Yes.
first component that you see here is to process geometry. Let's say this component here. This is a Rhino or Grasshopper Python node, and it imports Rhino.geometry because it understands what Rhino geometry is. This is actually Iron Python code because it works with Rhino geometry. Yeah.
Yes.
And in the next one, I am writing a different sort of Python, which uses NumPy and SciPy. These are two big libraries, two very important libraries, and NetworkX, three important libraries in Python, which are not available inside RhinoPython. Okay, and that is why I'm writing this code inside CPython. This is a CPython component. You see GHC Python component. Okay,
Brilliant.
and you might wonder how I transfer files from one to another. I transfer files between them using something that is called a Marshall file. I have written a library for this purpose, which is called Marshall Python. I will introduce it in the next session. It transfers one file from one version of Python, Python 2, to Python 3 with this code Python Marshall Python send 23, which sends something from Python 2 to Python 3. Basically, the other problem with the Python that is available in Grasshopper is that this is Python 2, Python version number 2, and the real Python that people use in the real world is Python 3 everywhere. And that's why we need to transfer. And from within this one, I have imported the same library, Marshall Python, which sends send32 sends objects from Python 3 to Python 2 to another Python 2 component, which is another GH Python component. Again, for visualizing geometry, which is a geometric thing for which you need Grasshopper, you need Rhino, you need geometric stuff. So that's why you need this kind of Python, which is not available here. So we keep these things separate from each other. This is the message. Geometric stuff separate from complex code. Okay.
Okay.
I know it's a bit confusing for now, but for now, just keep this in your mind that geometric stuff are available inside IronPython, and the other good stuff which are not geometric are not available. So unfortunately or fortunately, we have to separate these sorts of codes from each other. Okay?
Okay.
Okay, so let me see. See where are we? We stop here for now. Any questions so far? Sorry, I didn't ask earlier.
No, not yet. I need to go over these, all of this stuff that you explained,
Mm-hmm.
and then I will ask my questions maybe next session, or
Okay,
if I didn't find. Uh,
okay, very good. So may I recommend one other tutorial. There's a book from the Rhino from the company that makes Rhino, McNeil.
Mhm.
It's called Essential Mathematics for Computational Design.
Yes.
It has a couple of tutorials for, let me search it here. Essential Mathematics for Computational Design from Raja Issa. Let me see. Fourth edition. Okay. This is the book. I'll send it in a chat. It has a couple of tutorials for Python. You can follow those tutorials and you can follow basically the tutorial that I put in this repository.
Okay.
Where was it? The tutorial for making. There's another tutorial here as well, or depending on how much time we have from today to the next session. This is basically a challenge for making a spiral staircase for which there's more than one correct solution. Again, for this one, there's more than one correct solution. You saw this tutorial. This is the other assignment.
Okay.
But we will go through it together in the next session.
Okay.
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 Okay, good. So for now, let me stop the recording. Okay, see you next time.
Thank you, Bruce. Thank you